Okay, everyone. So in this video, we're going to go over calculating ages using the second part of LaserTRAMZ, which uses the input file from the first part of LaserTRAMZ in order to reduce that data. So the first thing we're going to do is we're going to go to that output file. We're going to open it. We need to delete this first row, or excuse me, that first column, and we need to delete the first row. Sorry about this minor inconvenience. There are some things that I need to work out in this program still, and that's because I've been focused on LaserTRAMZ for multi-collection, and that program actually runs way better than this one, so you have that to look forward to once that's available publicly. Okay, so now we have our file here. We've deleted that first column. We've deleted that first row. We can go ahead and close that. Just like the first part, we're going to hit run. Okay, so similarly, this opens up in our browser. The first thing we're going to do is we're going to choose the regression that we want to use for the uranium-lead ratios. I would recommend choosing exponential. If you want to use ellipsoids, you can click ellipses here. I should probably change that, but you know. And then we have point estimates, which is what we're going to use in this video. And these are just, it's a point estimate, right? It is a mean value taken from all the data in that time-resolved analysis. Okay, again, we have this box where we can input a file path. So we're going to copy that file path, paste. Okay, and again, we get this table that pops up. So now what we're going to do is we're going to input a sample ID identifier, identification, whatever ID means to you. Um, you know, yeah. So what we need to do is we need to input some string, some word or number or something that has an identifier that comes before the underscore dash underscore. So if we wanted Fish Canyon, we could type in fish, we could type in Fish Canyon, we could type in F, and it would search this column for anything that has that. So the caveat there, of course, is if you only want to visualize and reduce 91,500, you can't just type 9 because you'll also get 9435. Okay, so let's go back here. We're going to type in Fish Canyon. Okay, so this graph, like the last one, is you can move this around, you can pan it, you can scroll. If you want to set a hard limit on the X lim and Y lim, you can do that here, and every time you reset, it will change to that value. Something like 500. Okay. So there are your point estimates. You can also look at this data on Weatherhill Concordia if you desire. I typically, I personally don't use Weatherhill in my research. If you do, that's great. But the way that LaserTRAMZ is going to calculate ages is it's going to project up off common lead on through this data point onto Concordia, and it's going to give you that concordant age. Okay, it's pretty common. If you're unfamiliar with that, I recommend you dig into the literature a little bit. Okay, the standard that you want to use to reduce the data, you will input that string here. Okay, you're gonna get this little box that pops up. I'll go ahead and change the size of that so that it's bigger, but basically this just shows you mean, median. It's a box plot. Okay. Um, then if you have measured a different standard that is not zircon, zircon reference material. So let's say you've used NIST or something like that. You can input that value or input the string for that sample identifier, and it will correct that drift for you. This drift is based off a slope, and it's only going to correct it if the slope is statistically significant. Okay. I typically don't use this on the iCap. Our laser particularly has this active energy laser management selection, where the laser recalibrates its output energy as time goes on. So the drift, typically you'll see the analyses drift a little bit, and then they come down, and then they drift, and they come down, or then they come down and back up, etc. Okay. And there's really not too much drift that I've noticed in the iCap for these analyses. Certainly not within error of the analyses overall. Yeah, that's going to be really different in the multi-collector version of this program. Okay, if you have a good estimate for common lead, your 7:6 common lead ratio, you can input that estimate here. Okay, and again, it's going to project. It's going to be something like 0.9-ish, and it'll project down from that value. If you input that value, you have to have an error associated with it, or it will not reduce the data. Okay, thorium disequilibrium correction, you can do that here. So this is the thorium-uranium ratio in concentration, not isotope ratio, in the zircon. This is the coexisting melt. Yep. If you need to familiarize yourself with that, I recommend doing so. And then in order to use this, your input common lead and your thorium disequilibrium correction, you need to click this button here. If you have nothing input here, the program is going to, if you use this or you have nothing input here and you click this button, the program is going to approximate common lead ratio using the Stacy-Kramer's model. If you're unfamiliar, yeah, okay, that's it. Okay, again, if you've measured NIST in order to directly get your lead-lead mass bias, it works very well. If you want to do it, you can click this button and it will go pull NIST, calculate the mass bias using the 7:6 ratio in that standard glass. That's pretty much how to use this program. That's it. So what I'm going to do is I'm just going to hit approve data. And there you go. There's your ages. So it's got all the output data in your prior one. Here's your estimated common lead ratios, mass bias corrected ratios, fraction of common lead, etc., etc. So when you output, I'm just going to go over this very briefly. When you output this data file, this is your corrected age, fully corrected, concordant, projected to Concordia age for all of your analyses. Okay. Use that to report your ages. This is not your error. This is an analytical error. Do not use this. This is your fully propagated error. You will see that it's much larger. That is the error that you should be using. Okay? If you want to see all the details on the calculations, etc., you can see that on the GitHub page. Okay? Now, if I want to go do a different standard, just for example, 91,500. Okay, there's my two analyses I reduced in the corner of Concordia. Oop, yeah. Okay, so we're gonna approve. There they are. Okay, just like that. Okay, so again, similarly, once we're done calculating ages, go ahead and hit this button. Go to your LaserTRAMZ folder, and there are your ages. So we're gonna delete that guy. Oops. And here is that data. All right. And that wraps this up. If you have any questions at all, please email me. This program is very much under construction. The calculations are right, but there are some bugs, right? You saw the small graph, the little NaN thing. This program has not been the focus of my coding efforts as of late. Okay, so, and my email, in case you want to email me to ask any questions, it's lewisc2@oregonstate.edu. Okay, there it is. You can email me. All right, thanks, and happy data processing.